Mathematics Advanced Subsidiary Level, Paper 2, 2022, Part 3. Let's go on with question number 4. The polynomials fx and gx are defined by, and then they give you the two functions. Where a and b are constants, it's given that, and now you can even underline it, given that x plus 3, it seems to me, okay, pen underline, given that x plus 3 is a factor of fx, it's also given that gx is divided by x plus 1, the remainder is 6. Okay, that line was a little bit not so nice. Okay, it should have been moved up. Okay, this is a beautiful, easy question. So really, this is score mark. So make sure you can do this. This is, especially for this theme too, this is easy. Okay, so you will find it on page 386, and an excellent example. You can even look at example 23 in the textbook, in the AS-Level Mathematics textbook, and that will help you. Okay, so basically they say if you substitute -3, it's the factor and the remainder theorem. So this is the factor theorem, because if you substitute -3, you will get 0. Okay, so if I substitute -3, so it's going to be -3 to the power 3 plus a -3 square plus b, and that will be equal to 0. Okay, so it's -27, and then it's going to be 9a plus b, and that's equal to 0. Okay, I think sometimes it's better to work with the constant on the other side. So I'm going to just move it to, and then everything is positive. So let's call this equation 1 now. Okay, so I'm going to just swap colors just that we see better. So if I'm going to say g and I put -1, then I'm having a remainder of 6. Okay, so let's do it. So in g, there is g. I'm going to put -1, so -1 to the power of 3 plus b, -1 square minus a, and that's equal to 6. So this is going to be -1 plus b minus a, and that's equal to 6. And then I can simplify it further by saying b minus a, and now I'm going to say 6 plus, and that's going to become 7. Okay, and let's call this equation 2. And now I'm going to, let's just go solve equation 1 and equation 2 simultaneously. Okay, so basically I'm just going to say 9a, and now I'm rather going to work in red. I can see better in the red. So 9a plus b equals 27. And then b, then I just, -a, just swap the 2, plus b equals 7. So what will I do? I will multiply with a negative. And if I do that, okay, I'm just going to, I could have say again, 9a plus b equals 27, and it will become a minus b equals -7. Okay, so 9 plus, it's going to be 10a, that cancel out, and that is going to be 20. So I divide 10, and the value of a, that will be equal to 2. Okay, and now I'm just substitute a equals 2, say in equation, in equation 1. So then I'm going to have 9, and then I'm just going to have 2 plus b equals 27. I think equation 2 was easier, the values, but it doesn't matter. Okay, so it's going to be 18 plus b equals 27. So b is equal to 27 minus 18. So therefore, b is equal to 9. Okay, so there you have your value. You have a as well as B. This is score marks, especially for this part or this paper. Okay. Now, when I'm looking at the next one, they say when A and B are these values, find the smallest value of. So they want to subtract the two, and they don't forget they ask for the smallest possible value. Okay, not just subtract. But let's just first go and we subtract. Now, I prefer just to write down the functions quickly. So the functions fx equals x free plus 2x squared plus 9, and gx equals x free plus 9x squared minus 2. Okay, so then I'm going to say it's going to be gx minus fx. Okay, so it's going to be g, so it's going to be, and I'm going to swap again to red. I see just better. So it's going to be x free plus 9x squared minus 2 minus x free plus 2x squared plus 9. And if I simplify this, x free, just bring that negative in. I do a little bit long because I don't want in the videos for you to get lost. Okay. So, and then this will cancel out. Can you see that? So 9 minus 2, it's going to be 7x squared minus 11. Okay, so let's look at this statement. Remember, this was equal. You can put the equal sign there. Okay. Now, if you look at this, you will see it's a quadratic equation, but there's not a middle term. Now, if there's not a middle term, then this value will be, say for example, it's positive and the graph is like this, then this value, the value of the constant will be the smallest possible value. That's why I can end up by saying, therefore, the smallest possible, or the minimum point value is negative 11, and it's due to that it's not having a middle term. That's not the turning point. Okay, so that was question 4, and I'm just going to make it bigger. Okay, well answered. Oh, excellent. Most candidates successfully wrote down the 2 required equations and also solved them successfully. It needs mention that f is 0 was very often not seen. These candidates did not realize that the remainder is 0 if is a factor. Okay, so as soon as you put it in, you must, to say if it's a factor, it means the remainder is 0. Remember that. It was also occasionally seen that candidates use this equals 6 instead. Okay, it was not f, it was g. So make sure you go to the correct function. Another mistake that occurred regular was f3 equals 0 and f1 is equal to 6. So now, remember that you take it over. So if it was x plus 3, you put it equals 0 and the 3 goes over and it becomes negative 3. And you put the x plus 1 equal to 0 and it goes over the 1 and it becomes negative 1. So that was incorrect. Many candidates start off very well, but then made careless arithmetic mistakes or struggled to do the very basic simultaneous equations. That's why ordinary, you must conquer everything there. Okay, and then just number B, can just maybe show you here. It's moderately answered. A very common mistake was to calculate this instead of the required. So make sure you put the correct one in front. It's not addition. So many candidates also show a shocking lack in algebraic skills and could not expand the negative into the bracket successfully, also ordinary. Many candidates successfully bound the expression, but sadly did not realize that it is a quadratic expression with a minimum value if x is equal to 0. Okay, so it is just it's almost like it's almost like the turning point there. It's the lowest it will go. Okay, and that will go to at negative 11. Okay, so then there is the answers that they gave you, and hence the negative 11. Coming that if you put x is equal to 0, then it's negative 11. Okay, let's go to the next question. And now it will be back to the question paper. Let's start with question number 5. The equation of a curve is y is equal to 6x e to the power of third x. At the point on the curve with x coordinate p, the gradient of the curve is 20. Very important to underline. So the x coordinate is p, then the gradient of the curve is 20. Okay. Then they say show that. Don't use that. You must arrive at that answer. Now, as soon as you see gradient of a curve, your mind must say differentiation. So what am I going to do with this equation? I'm going to differentiate it. And can you see that you are going to follow the product rule? Now, you can check on page 481. And sometimes I see I even wrote an example there. So look at example 12. Okay, I just want to make that 12 looking better. Okay, so I'm going to start and I'm going to say, to find dy over dx. Now, what is the product rule? Can you remember? Okay, I'm breaking it up in this two parts, 6x, and that is the second part. So I rewrite the first one and I differentiate the second one. Then I rewrite the second one and I differentiate the first one. Okay, and now I'm going to start. So this is just rewrite. Now, what happens? Now, if you go to integration, and maybe I can quickly take you to that integration there. Can I just take you to differentiation? Sorry. I want to just quickly take you to the rules. It's differentiation. I want you to show you how to use that formula sheet. Okay, so if I'm here, I'm going to see, okay, it's differentiation. This is not, so I go on. Here is differentiation. Do you see? Okay. Now, do you see if I'm looking here, and unfortunately they always just give the basic one, but meaning that say there is 1, I put the 1 in front, but if it is 2x, then it will be 2ex. And this is why I mentioned to you, it's good to do it in connection with the textbook. So if you go to differentiation, the summary, and it's also very, very nice on the posters. Okay, so if you go to differentiation and you see on page 516, I'm going to go back and I'm going to go to page 516. Okay, so you will see on the summary there, page 516. There, that summary is saying it's so exponential functions. And then I'm saying to you, if it's e and it's ax plus b, if you d over dx, then it's going to be a, and then it's e ax plus b. So it's not integration. So you just put that constant in front of x in front. So basically, I'm just going to say, okay, so I just put it in front and I just rewrite, and it's a third x. Okay, this one I just rewrite. It's not different. And this one, if I differentiate, it's multiplies 6. So if I simplify now, so 6, so I'm going to get 2x e to the power a third x plus 6 e to a third x. Okay, now this equation is differentiated, but they said the gradient, because that's the gradient, is equal to 20. So let's put meaning dy over dx is equal to 20. So I put the 20 there, and I'm just rewriting it. But also, don't forget, the x coordinate is p. So, and I put x is equal to p. So I'm going to have 2p e 1/3 p plus 6e 1/3 p. Okay, now I'm just going to see if I can simplify. So let's take this out as a common factor. So I have 20, and then I have e to the power of 1/3 p, and then it's 2p plus 6. Okay, what can I do now? I can divide 2p plus 6, and I can divide 2p plus 6. Okay, so what can I do now? I can say e to the power of 1/3, okay, e to the power of 1/3 p, and it's 20, 2p plus 6. Okay, now before I'm going to, because if I check here, I say, 10, 2. Okay, let's see if I can get rid of that. So if I say 2 times, if I take 2 out as a common factor, and I take 2 out here, and I say I have p plus 3, and I cancel, and I have e to the power of 1/3 p. Do you see that? Now I can go from exponential form to logarithmic form, ln form. So I can have ln, okay, there, and I swap the side. So I say 10 over p plus 3, and that is equal to 1/3 p. So I'm basically swapping this and this. Did you notice that? But now if I want to get rid of the 1/3 here, I will multiply with 3, and I will multiply with 3 on the other side. Do you see? Or I divide the 1/3, and if I divide the 1/3 on this side, it's multiply 3. So therefore, to get p, it will be 3 ln 10 over, I can always put a bracket there, p plus 3. And did you see, when I see the word show, you don't use it, you arrive, you come to that answer. Okay, don't work with that answer. Work with the original and just end up. They actually just say, come to that answer. Okay. Let's start with question number B. Show by calculation that p is bigger than 2 and smaller than 2.2. Now, it's almost like you don't know they are in numerical solutions, chapter 13. So it's sometimes better to look just a bit down and say, use the iterative formula. Oh, that is chapter 13. So you can even first do this one and then come back to this one, because this is where it's that change of sign that show that it's a root. But a very good example to check there. It's on page 555, example 5. Excellent. It's going to really help you in the AS-Level Mathematics textbook. Okay, so basically I'm taking first that formula, and you will see it in that example also. So what I have to do, I have to get 0 on one side. So by doing so, it's almost like this. I take this p to the other side. So I have 3 ln, and then 10 over p plus 3, and then I subtract the p. And that's very clearly shown to you in that example. So now I'm going to substitute. So if I substitute 2, I'm going to get 3 ln, and then it's 10, and it's 2 plus 3, okay, minus 2. Okay, and then very, very important, press it on your calculator. So I get 0.079441541. Get used to writing out the full calculator display. Then I substitute this one. So 2.2, and I'm getting 3 ln, and then it's 10, and then it's 2.2 plus 3, subtract 2.2. And if I press that on the calculator, negative 0.238220597. Okay, and now I just say, and very important this reason. Okay, I say sign change. Indicate, therefore, indicate the presence. Okay, I just want to clean this. The presence of a root between 2.0 and 2.2. Okay, so that was a bit not so obvious, this question, I would say. Okay, now we go on. Use the iterative formula there with p. Now they tell you take p as 2.1 to find the value of p correct to 3 decimal places. Always very important to underline that. Give the results to each iteration to 5 decimal places. Okay, so let's start. Let's say p, red is just better, can see better. So p1 is equal to 2.1. And the formula is p, and then it's n plus 1, and that's equal to 3. I'm busy writing that. 3 ln 10, and then it's pn plus 3. Okay, that's what I'm going to. Now, very important that you use your calculator, because this one is having such long process before it's stabilized, and you have to write it down. So let me just start by doing the first one, and I just want to say, yes, just remember this is all p's. So now I'm just going to press in my calculator 2.1 equals, and now it's in the memory, and now I start 3 ln bracket 10 divide bracket, and then answer plus 3, close the bracket, and close again the bracket, because I was putting a bracket also there. So that's why I close 2 brackets, that one and that one. And then I press equal. And then I go and I say, okay, I start now. So P, let's make it 2, and that is going to be 2.0, or we can say P1, but doesn't matter, 0. They're not going to penalize. 0, 0, and then 5. Very important, that 5 decimal places. So 3. Then I just press equal. So I just go on. P3, it's 2.067, and then that 445. So it's going to be 4, and then that is going to become a 5. And then I go on, because I can check 3 decimal places. It's 4. Okay, so equals, and then I get 2.03924. Okay, and then I go on, and every time 5 decimal places. Okay, so let's just see that one, and then it's 2.05599, and then I go on, and then it's 2.04604, 4604, because there was a 36, and that made it a 4. Then just go on here, and always don't, if you don't stabilize, just, you have to keep on. So 7, okay, so, and then it is 2.05195, and then I go on, and then it's 2.04843, and then I go on, and it's 2.05052, and then I go on, and it's 2.049. Okay, let's just see, 4928. I'm just going to first just go on and then I'll check. Okay, and it's 2.05002. But I think I already got it, because if you go 3 decimal places, so go 1, 2, 3, no, still not. Okay, so let's just go another one. Okay, let's just see. Yes. And then I get 2.04958. 58. I think it's already now. Because if you look here, I just want to go another one on, because it doesn't matter. So I get 2.0498 and then 984. But if you go to 3 decimal places, so 1, 2, 3, okay, so this one will be 2.050. Okay, let's just test this one. 1, 2, 3, that 5s make, this one is 0.5, so it's 2.050. Did you see that? It's stabilized. And then 1, 2, 3, that one makes, so it's 2.050. So you can basically just write it there and see. But therefore, end with that. P is equal to 2.050. Very important. 3 decimal places. And that is your final answer. Let's go to the report and see what the report is saying to us. That was question 5. I just want to go back and question 5. I should have stopped after A. Okay, so let's just go. Moderately answer. It should be noted that this is show question. The answer is quoted. So candidates may not skip any steps or do no 2 steps in one in the establishment of the answer. Many candidates did not realize that they needed to use the product rule to differentiate the given expression first. A very common mistake was this as the only term seen, instead of requesting that you also do the product rule. Okay. It is advisable that x is exchanged to a p once the derivative is equated to 20, so because they state it. It could also be done at the later state as long as all the x values are changed to p values at the same stage, not in this step and then on one step. Many candidates had difficulty making the subject of the formula. Those who failed to divide the equation by 2 first also struggled to show properly how to simplify, just taking that 2 out, top and bottom. Many of those who managed to make the subject of the formulas successfully failed to convert, correctly to the exponential. It's again that exponential to log form. Many tried unsuccessfully to convert it into log form. Okay, so that was not that difficult. This was extremely poor answer. The majority of candidates realized that they first needed an equation equal to 0 before they could attempt the test for a change of the sign. The first step before they can test for a change of sign had to be this or this. The few candidates who realized that they needed to do this step first very often did not give the answer to 3 significant figures or better. This resulted in a loss of marks. Answers were often not given correct to 3 significant figures. Okay, this was moderately answered. Many candidates correctly calculated these values. It was seen, however, that candidates were not familiar with the notation of method of 2.02 as a solution, which resulted in the loss of all the marks. It was noted that some teachers still do not teach the candidates the proper use of their calculator to do this question. It's totally unnecessary to write down the substitution of each of the values into the equation for every iteration. It is extremely time consuming and also leads to premature roundings. Okay, so use your calculator. And then I'm just going to show you, okay, it's almost the end. Okay, in a numerical solution question, the answers to all these iterations should be written down to 5 decimal places required in this question. None may be left out or erased. It should be noted that this iteration approached the given solution from 2 sides. Candidates must continue to write down all the iterations till it stabilizes at the required accuracy of 3 decimal places requested in this question. In this case of this question, 8 and 9 iteration was the minimum required. It was seen that candidates did not realize that they did enough iterations to conclude with the solution and just abandoned this question after 9 and 10 iterations. Okay, but as I said, it was quite a lot to write. Okay, there's the answers. There also is the answers. So, and then it was just given all this, both values seen, 2.20, and then it's just going on to that 1, and then, or 5. And then this was the final answer, 2.050. And that was the question number 5. As your final exams approach, I want to highlight the importance of the Y = mx+c mathematics textbooks. If you don't have them yet, you can find them at the following bookshops. These textbooks will be your reliable study companions, guiding you towards mathematical success. For educators aiming for exceptional maths exam results, start using the Y = mx+c mathematics textbooks used by leading schools in your classroom. They are part of the NEET catalogue and can be easily obtained within your ministry's textbook budget. Make sure to communicate your request to your region's procurement department to empower your learners with the best educational resources. Furthermore, schools have the option to place direct orders with us, and we offer bulk order discounts. Reach out to us via email at the address below. Best of luck in your maths journey.